When you think of a second home for humanity, your mind probably jumps straight to the red planet, Mars. It's been the star of science fiction and space agency roadmaps for decades, a familiar, dusty world that seems just within our reach. But what if I told you we've been looking in the wrong direction? What if our best hope for an off-world settlement isn't the cold, thin atmosphere of Mars, but the scorching, acid-drenched world of Venus? It sounds completely insane, I know. Venus is the poster child for a planetary hellscape, with surface temperatures hot enough to melt lead and a crushing atmospheric pressure that would instantly flatten any lander not built like a deep-sea submarine. The surface of Venus is, without a doubt, one of the most inhospitable places in the solar system. The average temperature is a staggering 462 degrees Celsius, or 864 degrees Fahrenheit. But here's the counterintuitive twist, the secret that makes Venus so compelling. We aren't aiming for the ground. We're looking up, into the clouds. About 50 kilometers, or 30 miles, above the blistering surface, the upper atmosphere of Venus is surprisingly Earth-like. In this specific altitude band, the conditions for life become almost comfortable. The atmospheric pressure is roughly equivalent to Earth's at sea level, meaning you wouldn't need a heavy, cumbersome pressure suit to walk around. A simple oxygen mask and protection from the acidic haze would be enough. The temperature in this cloud layer is also remarkably manageable. It ranges from a pleasant 0 to 50 degrees Celsius, or 32 to 122 degrees Fahrenheit, a temperature range humans can easily tolerate and build for. Furthermore, Venus's thick atmosphere provides excellent protection from harmful solar radiation, a major problem for any long-term Mars colony. Mars has a very thin atmosphere and no global magnetic field, leaving its colonists exposed to dangerous cosmic rays and solar flares. On Venus, the dense blanket of air above would shield our future inhabitants far more effectively than any Martian habitat could. This solves one of the biggest long-term health risks of living off-world. Another huge advantage is gravity. The surface gravity on Venus is about 90% that of Earth's. This is a crucial factor for human health. Living in the lower gravity of Mars, which is only 38% of Earth's, would lead to significant long-term health problems like muscle atrophy and bone density loss. On Venus, our bodies would feel almost at home, mitigating these debilitating effects and making long-term habitation much more viable. But how do you live in the sky? The answer is as elegant as it is ambitious: floating cities. The concept isn't as far-fetched as it sounds. The key lies in the composition of Venus's atmosphere, which is about 96% carbon dioxide. This makes the air incredibly dense. Because of this density, a breathable atmosphere like our own, rich in nitrogen and oxygen, would act as a lifting gas. It would be buoyant in the Venusian air, much like a helium balloon is buoyant in Earth's air. So, you could construct enormous, lightweight habitats, essentially giant, sealed balloons or zeppelins, and fill them with a breathable mix of oxygen and nitrogen. These structures would naturally float in that sweet spot, 50 kilometers up in the Venusian sky. Imagine vast, cloud-borne cities, shimmering in the perpetual twilight of Venus's thick cloud deck. Entire communities could live and work inside these buoyant habitats, suspended high above the planet's deadly surface. These floating colonies would have access to an abundance of resources right outside their windows. The atmosphere is rich in carbon, oxygen, nitrogen, and sulfur, all vital elements for life and industry. Solar power would also be more plentiful and reliable than on Mars. Being closer to the Sun, the top of Venus's atmosphere receives significantly more solar energy. Unlike Mars, which suffers from planet-encircling dust storms that can block out the sun for weeks at a time, a floating Venusian city would be above most of the weather, enjoying a constant and powerful source of energy. The challenges are still immense, of course. The clouds we'd be living in are made of sulfuric acid, which is highly corrosive. Any habitat, vehicle, or external equipment would need to be coated with a material that can withstand this acidic environment, like Teflon or other specialized polymers. But this is an engineering problem, and one that we have the technology to solve. Getting there is also more efficient. A trip to Venus requires less energy and can be done more frequently than a trip to Mars, thanks to favorable orbital mechanics. Launch windows to Venus open up every 19 months, compared to every 26 months for Mars, and the journey itself can be shorter. This would make resupply missions and transportation of people and materials more practical and cost-effective. So while Mars gets all the headlines with its rovers and dreams of red deserts, perhaps our true future as a multi-planetary species lies in the golden clouds of our sister planet. It's a vision of humanity not as conquerors of a new world surface, but as pioneers learning to live in its sky. It forces us to rethink what a colony has to be. Instead of terraforming an entire planet, we would simply be finding our perfect niche within its existing environment, creating buoyant havens of life in an otherwise hostile world. The idea of floating cities on Venus represents a different kind of human expansion, one that is elegant, resourceful, and in many ways, more sustainable than trying to tame the Martian frontier. Thank you for watching. If you found this journey into the clouds of Venus fascinating, be sure to subscribe to Space Repo for more deep dives into the future of space exploration.